perform another escape, but this time we'll do it with the crew implementing the command. So of all the things that have gone on relative to the development of the ATV, there has been very close coordination in ensuring the spacecraft will be safe. And we talked a long time early in the program about whether or not we needed to try to create a target for the ATV to dock to, and we agreed with this approach to ensuring that we will fully understand what the spacecraft is actually going to do in orbit, and that we practice these specific aborts or escape scenarios to ensure that they would work, that approaching the ISS on its first flight was a safe thing to do. And to go a little bit to Todd's comment, remember DART was a totally automated vehicle. I mean, we turned it on and sent it on its way, and sure enough, it had an interesting life. That is not the case with ATV. It can be commanded from the ground, will be commanded from the ground. It is automated, so it knows what it's supposed to do, but along the way, particularly on this flight, it's going to take certain steps and stop, and certain steps and stop, and certain steps and stop, and we're going to look at the data and ensure it's acting the way we expect it to act. And anywhere along that way, either by ground command or the crew, we can implement an abort and have it fly away from space station while we figure out whatever issue that we were worried about at the time. So we're absolutely confident with the safety aspects of this spacecraft. When you get to those aspects about mission success, are you actually going to get there? Or once you get there, are you going to be able to stay the whole time? Things like that. Then we were able to give more of that responsibility to ESA and say, okay, this is a mission success thing. So if the mission's successful, then as Alan went through in some detail with you, it's the provision of a certain amount of logistics to ISS, a certain amount of prop to ISS, a certain amount of water. So it was up to them to decide how much work they wanted to go into relative to ensuring mission success. But when it came to safety, that was an effort amongst all the partners, all three of the partners, Roscosmos, ESA, and NASA.
Thank you very much. One more for you, Mike, and then a couple real quick ones for your colleagues. If ATV gets off around the 22nd and Demo 1 and 2 go on roughly when you think they will, when in a perfect world would you want to move the shuttle to, all things being equal?
Let's see, Bill, as I recall, the way it works is the window for the docking occurs on the 15th of March, and giving the timing, I believe that results in a launch of shuttle on the 16th Eastern time. So I believe that would turn out to be the 16th Eastern time for the shuttle launch. But anyway, just as soon as we can after docking is when we would plan for the shuttle launch. And as I said earlier, it's not just the launching, and it's not just Demo Day 1 and Demo Day 2. We got to get all the way to ISS. If anywhere along the way we find out that we need to back away and think about it, then we would like the shuttle team to continue to hold the earlier launch date. And then at some point, of course, we'll have to make that call. But as long as they're holding the earlier launch date, then we have some flexibility to have them fly earlier in the event that ATV needs a little time to loiter and think about what the data showed them. So I said all that to say is we're not in any rush. We're not going to get ATV to orbit and force it to ISS. If we see anything along the way, the objective, the primary reason for me trying to put the ATV before the shuttle was so that we try to have this first pass to ISS, such that if we learn anything along the way, I can save the loiter fuel, the fuel on board, to loiter and go work the issue, to work a real issue. If I let ATV launch and I go ahead and fly shuttle early and ask ATV to wait till shuttle flies and undocks, then ESA has to expend quite a bit of their fuel just loitering, still waiting for the actual Demo Day 1, 2, and actual rendezvous. So it makes more sense to try to get this flight done before the shuttle. If they're successful, then shuttle can come in right after. If they're not, then they can go loiter, and we can work whatever that issue is, let the shuttle guys come in and get that flight done, and then we'll figure out where we are relative to the Soyuz and whether we can plop into another window that's open right at the end of the March, early April. There's another window for the ATV. If we were ready and we got the shuttle done, we'd maybe try to sneak into there. So that's kind of the thought process.
Thank you very much. And then some really quick nuts and bolts questions for the ESA folks. The red abort button that the crew has some control over the approach. Can you tell me what is the closest, the minimum distance the thing can be away and still use that technique to make it back out again? I mean, you mentioned earlier there was some minimum distance where it makes more sense just to come on in, but what is that distance? And also, out of curiosity, what is the lag between the time the crew initiated that procedure and when the thing actually changed its velocity? What's the lag time? Thanks.
We have what Bob described as the crew handoff point, which is 1 meter away from the spacecraft. So up until then, they can fire the cam, which gives the spacecraft 5 meters per second velocity away from the space station, and it will be completely safe and get into a safe orbit by itself. I mean, the time to actually command the abort is very quick, really. I mean, we've trained the astronauts very well. Their reaction time is very quick if they see that Jules Verne is outside the corridor. So it's really a matter of seconds before them pressing the button and Jules Verne starting to leave.
And maybe I can just add that when we actually did the analysis to determine where the chop point should be, we took into account the reaction time of the crew also. So the 1 meter point is really the last chance to do an abort.
Thanks. Todd Halverson of Florida Today. I guess this one is for Mike. The ISS Independent Task Force raised concerns about ITAR regulations and restrictions on interaction between NASA and the IPs in regard to ATV operations. And I was wondering if the U.S. was able to sufficiently share information and lessons learned from the DART mission, and whether those restrictions have been eased since the task force put out its report a year ago.
Well, I wouldn't say the restrictions were eased. We followed all the rules and were able to get all the appropriate agreements in place so that we could appropriately share the data. In the case of the DART mission, there were some restrictions, but we were able to deal with that as well, and was able to communicate what the underlying cause of these anomalies were, so that our ESA counterparts could go back and assess the events that occurred and got us into the issue with the DART mission. And the DART mission had a lot to do with the systems engineering issue. When you go back and look at it, you know, the system, it was how we implemented, I didn't have anything to do with it, but how the system was put into place in a relatively late change in the process, and it wasn't looked at across the entire system to see the effect of that change across the entire system. That is essentially what was communicated back to our ESA counterparts. And in fact, it's a lesson for us all to keep in mind whenever we are dealing with a complicated spacecraft like this. But in the end, we were able to communicate within the rules of ITAR what we needed to about the DART mission. And in addition to that, really one of the bigger issues they brought up was the ability